Hey everyone, welcome back to another math video. In today's video, we're going to be talking about a special case that you get when you're multiplying a binomial times a binomial. And we call this special case the sum of squares. Let's go ahead and take a look at it. So here we have a binomial times another binomial. What's special about this problem, or these two binomials, is that they're exactly the same thing. And this is here what we call, when we multiply this, we're going to get what they call the sum of squares. Okay, so let me write that down. Sum of squares. And the reason why this is a special case is because you can actually take a shortcut when you're multiplying a problem like this, when you have two binomials that are exactly the same. But first, let me go ahead and multiply it normally by using either distributive method, property box method, or FOIL. Some of you, doesn't matter which method you use, you'll get the same answer. But I'm going to go ahead and I'm going to use the distributive property. So in rewriting, I'm going to rewrite the first one, y plus 9 times y plus 9. Remember, when we use the distributive property, we sort of split this first one up into two pieces. So it's going to be y times this y plus 9, and then it's going to be that positive 9 next times that plus y plus 9. Okay, multiplying these out, now I do the distributive property twice. Y times y is y squared. Y times 9 is 9y. Over here we do 9 times y, that's plus 9y. 9 times 9, this is 81. Okay? And what's special about this, when you have two of the same exact things multiplied against each other, is that you get the two middle terms will always be exactly the same every single time. Okay, so what we actually end up doing, you can combine those. Y squared plus 18y plus 81. And that's how we solve this problem. Now, you could do all this work and you'd still get the question correct. But the reason why we cover special cases is because if you notice the special case, if you can identify that, hey, both of these are exactly the same, then you're allowed to take a little shortcut. Okay? You don't necessarily need to do all of this work. And we're allowed to cut some of it out. Okay? So what we're going to do is, when you see that, hey, these two are exactly the same, what we can do instead is we multiply. We really just need one of these, actually. The other way that you might see this written is y plus 9 squared. Okay? Which means y plus 9 times y plus 9. But let's say they just gave me one of these. What I do is I multiply this first term by itself, y times y, that gets me y squared. Then I multiply these two together and I double it. So I'm going to do y times 9, that equals 9y, doubling it, so times 2, you get 18y, and that becomes your middle term. And then for your last term, 9 times 9. You do the last term times itself, plus 81. And I wrote this out, but if you memorize what to do to find each term, this becomes a much faster problem. I don't have to do as much work. So this is it with all of it written out, but let's say I look at another problem again, and that's the benefit of working with the sum of squares problem. But here I have another one. I can do p times p, that's p squared. P times 15 is just 15p, but then I have to remember that I got to double it. So 15p doubled would be 30p. And then lastly, 15 times 15, you can find that in the calculator or on your phone. 15 times 15 would be 225. And this, compared to the amount of work I did the very first time by using the distributive property, or if you did the FOIL method, or if you even use the box method, it's much faster if you're able to realize that this is a special case because we end up with the sum of squares. Alright, and remember, this is just another way to write p plus 15 times p plus 15. So hopefully now you kind of understand how we can use this special case to get to our answer a little bit faster. Alright, like I said, if you don't remember these special cases, you can still multiply these two binomials by each other, and you'll still get the same answer. However, being able to identify these special cases not only makes it faster to multiply, but you're going to see later that if you can remember these special cases, it'll make it easier to factor, which is sort of the opposite of multiplying when it comes to polynomials. There's one more special case that I want you to check out, and that is the difference of squares. So watch that video if you feel comfortable with the sum of squares, and we're going to talk about what the difference of squares is.